So now this question, let fx equals to x square minus 4x minus 5. The following diagram shows part of the graph of f. Find the x-intercepts of the graph of f. Find the x-intercepts. So the x-intercepts are these 2 points, and basically these are the zeros of the particular polynomial. So basically, if I have been told to find out the x-intercepts of any graph, it means I need to find out the zero of that particular graph. Now where I will find the zero? At x points. Okay, so that's why if we at this two particular point, the value of fx is equals to 0. So we will equate this x square minus 4x minus 5 is equals to 0. Now we just need to do a simple middle term and our answer will be in our hand. So x square minus 5x plus x minus 5 is equals to 0. So we are getting x into x minus 5 plus 1 into x minus 5 is equals to 0. So we are getting x plus 1 into x minus 5 is equals to 0. So from here we can write either is this equals to 0, so x plus 1 equals to 0. So from here we are getting x equals to minus 1, or x minus 5, this is equals to 0. So from here we are getting x equals to 5. So this point is 5 comma 0 and this point is minus 1 comma 0. So x intercept of f are minus 1 comma 0 and 5 comma 0, or you can directly write minus 1 and 5 because x intercepts are asked. So this, in this way you can do this particular problem. So remember, if we need to find out the x intercepts, it means it is zeros of the particular graph. Now where the zeros will be find out, like the value of the function will be 0. So that's why I have equated the value of the function to be 0. So now x square minus 4x minus 5 is equals to 0. Now how I have got this particular middle term? Just coefficient of x square, that is 1, into the constant term, that is 5. So basically it will be 5. So 1 into 5 and 5 minus 1 equals to 4. That's why I have taken this value. So in this way this problem is done. Now the next problem. In the next problem, find the equation of the axis of symmetry of the graph of f. So the axis of symmetry is just by this line. By this line we can find out the axis of symmetry. By this particular line we can find out the axis of symmetry. So if we know the point of x at this, like at this particular point, the value of x we need to find out, as well as this is the minima point. So if we know the minima value, then obviously we will know the value of x, and then it will be the axis. So for that, our fx is equals to x square minus 4x minus 5. So f dash x is equals to d dx of x square minus 4x minus 5. So we are getting 2x minus 4, and f double dash x, this is equals to d dx of f dash x equals to 2. So it is greater than 0. It means at this particular point, like at this particular critical point, 2x minus 4 equals to 0. So it will be 2x equals to 4. So x equals to 2. At x equals to 2, f double dash x is 2. That's why it is greater than 0. If f double dash x is greater than 0, already I have told in previous videos, it means here the function have the lowest value. The function have the lowest value. Has the lowest value. And as you can see, this is the lowest value point. That's why this point, the value of the x is x equals to 2. From here we have got. Now how we got the critical point? Just by equating f dash x equals to 0. And whether there will be maximum point or minimum point, just we need to do the double derivative. Okay, so at this particular point the value of x is 2, and obviously this is x equals to 2 line. This is x equals to 2 line. So find the equation of the axis of symmetry of the graph of f. This is nothing but x equals to 2 line. Done. This problem is also done. So in this way you can do the problem. And in many cases you can also, if you forget this particular theory, then you can also do the thing like this point is -1, 0 and this point is 5, 0. So obviously this is somewhere the middle point of this particular 2 points. So you can directly write -1. You can directly write -1 plus 5 divided by 2. So the x value is equals to, this is 4/2 equals to 2. So x equals to 2, another value. So from here also you can do this particular problem, but this is the right process to do this problem.